Hi everybody, in this video I'm going to try to walk you through the 74LS47N 7-segment display driver. You can see I've got some information built already in Multisim, and this is just a reference for you. Feel free to pause at any point in time and stop and just draw this information in, because it's important that you understand how this works. So what we have for the 7-segment display driver, over on the left-hand side, I've just put a box over that. It represents some kind of circuit. Maybe it's like an asynchronous counter like we've been doing in class or whatever it is, but it's going to produce a binary number. So it's going to produce ones and zeros. And if we arrange those correctly, then we know that we have a 1 spot, a 2 spot, a 4 spot, and an 8 spot. So what we've been using so far has been called the DCD hex display, which is great on Multisim, but it's not an actual device that we have to build with here. So we have what common anode and common cathode 7-segment displays is what we have in our classroom. So how do we get then, the question is, how do we get 4 digits to go into 7 segments easily? Okay, and that's what the 74LS47N 7-segment display driver does for us. So some information about this thing. First of all, on the left-hand side, you see the symbol names A, B, C, D. So that represents your 1s, 2s, 4s, and 8s outputs out of this circuit that's over here on the left-hand side. So those 1s and 0s we're going to tie directly into A, B, C, D. Again, A is your least significant bit. It is the zeros, or excuse me, the 1 spot. Okay. Over here on the left-hand side are a few more inputs. You can see I put a note down here. That's called the lamp test, the ripple blinking input, and the ripple blinking output. You can go look at those. In fact, I did a quick Google search just to figure out what those things are. And here's one of the sheets that I found from Texas Instruments over the device and how it works. You can see on the first page, obviously, there's like the pin outputs, which we would need to know if we're ever going to use this chip. That's what it looks like. And down here it gives you some information over what it's going to produce. So it's going to produce a signal that looks like this. Notice 0 through 9 look very good. 10 on, not so much, right? Those don't look correct. So this is going to be a great device to use if we want to just display a digit. But if we ever want to get into hexadecimal stuff, it's obviously not going to work. We got to figure something else out. There's the information down here on what the blanking input and the ripple blanking output do. Information that's good, but it's beyond the scope of this course. We just don't use it here. Okay, so here's what you need to know. They have bubbles. These are inputs. This chip here is relying on us to tell it which each signal coming in is, whether it's a 0 or a 1. Okay, and because of these bubbles here, that means they're active low inputs, which means a 0 is what activates those things. Well, we're not going to use those, so we want to tie that to VCC. In every single case in this class, we'll tie that to VCC and we'll never use them. So, but we do have to tie them to something. If we just can't leave them open. Okay, on the output side over here, output A through output G, we have bubbles. And those bubbles represent built-in NOT gates. Inside the chip, there's a NOT gate at the end of each little circuit. Okay, what that does is, because these are built to use the common anode, which is a 0, turns these segments on. That creates the 0 that's needed for the common anode 7-segment display. So it's really specifically built for that. We do have to have resistors in place for each of those 7 segments to protect it, somewhere in the neighborhood of 200 ohms. 180 to 220 is a pretty typical value. Anything in there is going to be fine. And we got to make sure, of course, our common anode is connected to VCC up here so that everything works correctly. Okay, so that's the 7-segment display. Again, it takes a number like 1010 and it turns it into the 7-segment display in the outside that would run this. So 4 inputs to 7 outputs, really, really convenient. Okay, and again, to show you what's going on the inside, to give you an appreciation for this, here's what it looks like. Okay, that little chip contains all of this information on the inside, and you can see there's the NOT gate at the end of each one, right, like the bubbles. Okay, so obviously you should be thrilled that this kind of a circuit exists, because otherwise you get to do this by hand every single time. To give you a quick demonstration before I quit this video here, I built a little counter. Nothing special about it. It's a 4-bit counter, uses D flip-flops, and it counts up. And I have the DCD hex that we've been using all along. So notice we have 4 outputs, the 1s, 2s, 4s, and 8s, and in the DCD hex we just plug those directly in, and that's really simple. So what I did is I tied off of those 4 and used the 1s, 2s, 4s, and 8s as my inputs. You'll notice these are tied to VCC again, and then I just copy-pasted the rest of the circuit from that other thing. And when you run it, you see them side by side. They produce basically the same thing, 0 through 9, but once you get above 9, weird stuff starts happening, right? So DCD hex is great if you want to display A through F. but this will work for 0 through 9, and for what we're doing in this class, that's all you're supposed to do anyway. So that's a little demonstration of the 74LS47N 7-segment display driver. Hopefully that makes sense, and you're able to use this circuit, use this driver to build some circuits, because we're going to build some physical devices in class. And again, this is the equipment that we own. This is what we have, so we better understand how to use it.